Hello and welcome to our ActiveDevelop webcast about MvvmForms. My name is Klaus Löffelmann, and as you can probably tell by my accent and my last name, ActiveDevelop is a German-based software development company. So if you know MvvM, you probably already figured out that this webcast is about applying the MvvM pattern to Windows Forms. And that might make you wonder why we would do such a thing. Why are we thinking we have to bring a modern development paradigm to something as old as Windows Forms? And that's indeed a good question. So, Windows Forms is still one of the most used UI techniques in the .NET world. Millions of lines of WinForms code are still actively developed, and one of the most frequent reasons for that is teams simply don't have the resources to throw their current apps away and start from scratch. And to be honest, why should they? That would be expensive and a very big risk. So the thing is, often teams have to introduce their legacy monolithic application to the mobile world, at least part of it. So we asked ourselves a couple of years ago, what if we take a current development pattern which is used in that modern world of WPF, Windows 10 Universal Apps, iOS or Android apps, and simply apply it to Windows Forms. That way, teams could modernize their Windows Forms apps in those parts they have to bring forward, and they could do it risk-free and step by step. And then they could easily take the modernized part and reuse those in modern mobile-first, cloud-first apps. And that again would enable them to run it on Windows 10, iOS and Android. So the important thing is, we wanted to find a way which is feasible, where the team can be productive from day one. So the key to solving the problem is a software design pattern called MvvM. That's short for Model View ViewModel. And to understand that, let's take a look at remote control models as an analogy for that. See, when you're driving an RC car, you need a remote. That thing completely works by itself. It's sending its commands and changes its parameters based on how you steer. But it doesn't really care what kind of model car is attached to it or receives your commands. It can be an off-roader, a truck, an F1 racing car, or even a tank. Just by changing or adjusting the frequency, you could use the remote for every model again and again. If we compare that now with software, the typical Windows Forms paradigm does not allow that. Code behind directly manipulates the controls on a form. And there is no easy way to take just the front end and replace it by a Windows 10 Universal App front end, or an iOS front end, or an Android front end. But what if we kind of remote controlled what we call view in MvvM, which equals our model cars, with a remote, which we call ViewModel in MvvM. So if we had the same loose coupling that we have with a remote control and a remote control car. Take a look. So let's take a look at a sample app, which is a simple form of a calculator. The user can enter a formula, a math expression if you will, hit calculate and see the result in the output label. Here on the left side we have our view, which can be a form or a user control in Windows Forms. And we have our view model, the remote control if you will, on the right side. And now we do a data binding between the controls on the view and the properties of the view model. Maybe you know about the built-in data binding in Windows Forms, but unfortunately that is not compatible with what we need in modern apps. That's why we at ActiveDevelop came up with something new, and why MvvmForms has its complete own binding engine. So with this MvvM binding, you can control not only the data flow between the properties and the controls on the view, you can also invoke methods in the view model which are bound to command properties. Now, with this MvvM binding in place, let's see what happens when the user enters a formula he or she wants to calculate in the text box. Since the content of the text box is bound to the formula input string of the view model in two directions, the formula input property now contains what the user typed in. Now the user hits calculate. Since the command button is also bound to a command in the view model, clicking on the command invokes the command proc. This method then takes the formula input, calculates it, and stores the result in the result property. Since the result property again is bound in one direction to the result label in the view, the MvvmForms app displays the result. So basically the workflow is exactly how you would do it in Windows Forms code behind. But the ViewModel code is located in its own assembly, and since this assembly is from a type we call portable class library, we can reuse that ViewModel code in all sorts of other project types, for example Windows 10 Universal apps, or even on an iPhone or an Android phone. And we do not have to change one line of code to make it work with that. We just need a dedicated Windows 10 Universal app view for that, like this. Again, we have a view, this time for a Windows 10 app, and we bind our already existing view model against it. The rest you already know, the workflow is exactly the same. So, to make this work, properties cannot be simple properties. They must possess a mechanism which allow them to notify the view when a property got changed, so the view can update its content accordingly. To this end, the view model needs to raise an event in a standardized way, and for that a view model class needs to implement an interface which is called iNotifyPropertyChanged. This interface dictates a class to implement this event, which the view can consume when the view model has been bound to the view. So let's switch to Visual Studio to see how this works, how we can do the binding with MvvmForms, and how we can later use some of the MvvmForms base classes to simplify the coding of ViewModel classes for large business applications. So, as I mentioned before, if you want to use MvvmForms, you need to add a certain type of controls library to your project. When we came up with the concept of MvvmForms, we wanted to ensure two things. Firstly, MvvmForms should be working without going through the process of an installer. Secondly, if you wanted to use MvvmForms, solutions using it should be able to compile on build servers without any additional configuration steps. To this end, we decided to go for NuGet as a container for MvvmForms and not a v6 installer. And here is one tiny little catch. At the moment, and this will be most likely changing in the future, a NuGet package can really not conveniently deploy the Windows Forms toolbox. But since the binding engine in MvvmForms comes as a component which needs to be dragged from the toolbox into the form or the user control, which is your view, we need the toolbox to be deployed. So, directly after you created a Windows Forms project, you need to add the MvvmForms NuGet to the project, compile the solution, find the project's binary, and drag the main MvvmForms assembly into the toolbox. And this looks like this. So I first start to create a new project, and this will be a C# Windows Forms project. So I go to Classic Desktop and select Windows Forms project. And this project I'm gonna name MvvM Calculator. And I want to create a directory for that solution, and now I'm clicking OK. So here's my WinForms project, and as I said, now I want to add the MvvmForms NuGet. And for that I'm opening the context menu on the Solution Explorer and go to Manage NuGet Packages. Then I'm going to find MvvmForms, this one here, and I click Install. Okay, so this adds my MvvmForms base library to my calculator project. And as you see, if I'm going back to the WinForms designer, the toolbox has not been populated. In fact, what I have to do, or what I can do, is actually create a new tab here. And this one I'm calling MvvmForms. So, and now I'm going to compile this solution, or the compiler creates the bin files in the project folder, and I'm going to open this folder in the Explorer now. Well, that landed on the other screen. Let me just put it here. So, and if I now go to the bin file and the debug folder, I'm getting the main MvvmForms DLL here, and that one is called ActiveDevelop.entityFormsLib.dll. And this one I can now easily drag into the newly created toolbox tab. And this is all which has to be done in order to populate the toolbox icons. And all the components and controls which are in MvvmForms I can now use. So, as I mentioned before, a classical MVVM software consists of two, basic components. The first one is the collection of the views, and that is something that can be, exchanged for future UI paradigms. One component of the solution is very static, actually, and that is the view model. And we already created the WinForms project, which is the container of all the views that we are going to create, just for the purpose of, being able to use from Windows Forms. But the actual view model library is still missing. So I'm going to add another project to my solution, and this time I decided to go for Visual Basic. And again, I'm picking a project from the Windows area and Classic Desktop, but this time I'm going for a portable class library. So portable class library actually creates a type of assembly which can be used in all different kinds of projects. It can be used in WPF applications or WinForms application. It can be used in Silverlight applications. It can also be used in Xamarin applications. So if you are developing for iOS or for Android and your main library is the UI for those platforms, then adding the same portable class library which you already used in a WinForms app can be added to that project as well. So that's the really cool property of a portable class library, that it can be reused in basically every kind of project, and it doesn't need to be changed for that. It can just be picked and assigned to the solution and be referenced. So I'm going to name this MVVM calculator VMlib for view model library, and add this to our solution. And here actually you see what I just said. These are the targets where this view model library can be used. So in every .NET Framework 4.5 project, that can be WinForms, that can be WPF, in a Windows 8 or a Windows 10 app, Windows Phone Silverlight, Windows Phone 8.1, and even in Xamarin, Android, iOS. On all those targets, I can use this class library without changing it ever again. Okay, so I'm hitting OK now, and there we are. I'm going to rename this main view model, and as I said before, yes, I want If we have a view model, this view model is communicating in a way with our view. And to this end, the view model raises events to notify the target, which is listening for the events whenever a property changes. And there is a standardized way to do that, and this is by implementing an interface which is called iNotifyPropertyChange. And I'm going to implement that in Visual Basic. It is done with the implements keyword iNotify property changed, which means there will be an event, and this event is raised whenever the property changes. So I already prepared, so I don't have to type that much, a couple of backing fields, so I know which properties I have to implement. And implementing the properties is now something that takes a little bit of an effort, because every time the backing field has to really change, then we have to detect that and have to raise the property by ourselves for every property we want to implement in the view model. And this looks a little bit like this. So I'm implementing the first property. This will be the result property, and it should be of type string. Getting it is quite simple. I'm just returning the backing field. But assigning it is not that simple. Well, it is simple, but it's a little bit of an effort to type the code for that. So if not object dot equals my result, comma, value, then, and now we can assign value to my result. And since the value of the property really change, and here is where I really like Visual Basic, we can raise the property changed event, and the sender is the class. This would be this in C#. And now I have to create a new instance of the property change event args, and here we just pass the name of the property. We could do it with simply typing the name of the property now, but that's a problem if we ever going to rename the property. So in Visual Studio 2015 or in Visual Basic 14 or in C#6, we have the convenience of the really cool name of keyword, and this just takes the element, in this case the name of the result property, and returns the string, or returns it as a string. So whenever I'm going to rename this property into another name, then this reference changes as well, and my code doesn't break. So that was the first one. The second one will be the property of the entered formula. And it's basically the same. So much for our view model. We have the first two properties we've implemented now. What's missing is the property that actually implements the command. So the command is a little bit different. It's not that on binding any information is exchanged between the view model and the model. It's more that a link between them is established, and whenever the user requests a command to be executed on the other side, that can be done by this link. So binding a command is not really interchanging any kind of data besides the well, what is to be executed in the case that the user really requests the command to be executed. It is just the link that's established. And for that to end, I need a helper class which is called a relay command. We already have in the .NET framework an interface that dictates how a command which works in a view model should be implemented, and that interface is called iCommand. But this iCommand is just an interface. So what we really need is the actual code for the relay command, and that looks like this. Let me just, so I don't have to type it, get it from the toolbox, and here we got it, and I can just, import that line of code to make the iCommand interface accessible. So relay command works like this. I'm going to define a property as type relay command, and the relay command itself gets instantiated by passing it an execute action and optional another action that is responsible for finding out if in the current context the command can be at all executed or not. And if it cannot be, the related UI element can, for example, be disabled or rendered invisible. And if again the command can be executed, it can be enabled. So the other part is the actual execute action. Whenever a command button, for example, on the view is clicked, and this command is actually bound to a property of type relay command in the view model, then clicking the command just leads to the execution of the action delegate, which is defined by the relay command. The one thing then we have to do here is at first, let's uncomment this. So we have a backing field for the calc command, and this now is just another property I have to implement. Calc command as, you know what? Let's just pull this from here. So we have the calc command, and as you can see, it is exactly implemented as every other property. And we have the actual command proc. This is the delegate, or well, actually, this is the method which gets executed the moment the user presses or invokes the command, for example, by pressing the button that is bound to the command in the view model. Okay, so let's clean this up. And by the way, when we go forward with this sample, then you will learn that you don't have to go to all this effort for every property that needs to be implemented in the view model. Rather, we will have a library that's called MvvmForms base, which holds a bunch of helper classes and methods that you can use in all kind of scenarios. One of those things is calculating a formula which you have as string. So there will be a method that enables you just to, pass a string expression like 5 plus 5 times 5 divided by 5 and so on. And simply you can call calculate, and then it'll return the actual result of that formula. Since we don't have that implemented in our first little scenario, but we need to calculate what the user entered, we have to fake this. And for that is this little module calculate faker, which always returns 42, but that of course will later change into, calculating the actual result, what the user actually enters. For now, the view model is ready. So let's see if this compiles. Okay, so much for the development of the view model. Now let's focus on the view. So in MvvmForms, a view is actually nothing different than a form or a user control. In the same way, you know it from code behind. You don't need special controls to build up views, and you do not have to use subclassed forms or user controls to make them usable as views for MvvM. The command button is one exception of this, but that does not mean you could not use the standard Windows Forms button in MvvM scenarios. Using the command button is just more convenient and more compatible what you know from XAML-based UIs like WPF or Universal Windows apps. So let me quickly steal the controls from another example to save us a little time. And then we are good to go. And here you see every control I used here is really a plain out-of-the-box Windows standard control. And that means for your team, they can very quickly turn every existing form or user control into an MvvM view, really without redesigning what you already have. And that is a real big plus. So what does a form actually let become a view? So, and for that is the MvvM Manager component. The MvvM Manager component of MvvmForms holds the binding definition between the view and the view model, and it also holds the binding engine, which transfers the value between those endpoints. Let me drag that into the form, and then it shows up here in the component tray. One thing I'd like to add is the MvvM Manager also acts as a so-called property extender. So property extenders you probably already know from Windows Forms controls like the error provider or the table layout view. And the moment you place a component on the form which acts as a property extender, controls are getting additional properties. And in our case, when we place the MvvmForms component on the form or on a user control, each existing control, and it doesn't matter if they are standard Windows Forms controls or third-party controls, will be automatically getting one important additional property, and that is called property bindings. So this property bindings allows you to set up the binding between the view property of each control and the properties of the view model. But in order to provide a rich designer experience, the MvvM Manager needs to know about the view model's type. And it is extremely important that always compile after you modified your view model, so the type discovery algorithm can really detect the latest changes to types and to properties you might have made in your view models. So let's set the data context type property for our example. And as you can see here, the designer dialog helps you to identify which kind of view model type are available for your view based on the references. Types in italic font reflect those which implement iNotify property changed. So our main view model did actually only implement iNotify property change. So it is listed here in italic font. But since implementing this interface manually is or would be too much of an effort every time, we will soon learn other types your view model can inherit from, and those are called bindable base and MvvM view model base. And if your view models use those types, they would be listed here in bold typeface, and so they're very easy for you to identify. So for now, I'm picking the main view model, and now I'm prepared to do the actual view model view property assignment. And as I said before, to that end, we need the property bindings of each of the controls of the view, and the actual binding goes like this. For each of the controls, now I'm clicking the property bindings and calling the designer dialog. And on the right side, you will always find the list of properties and the way the properties have to bind against the control listed in this tree view. And it is a tree view because you could drill down into property paths. And on the other side, we have the list of properties that the control provides. You can always type in the property name, and you're getting then all the properties where this text occurs within the property name. I need the text property on that side, and I need, in that case, for the result label, I need the result property. And then there is a setting which controls how the binding should be performed at runtime. So there are actually a couple of binding modes. The most important ones are two-way and one-way binding. And then there is the so-called update source trigger. So when we have a control, then this source trigger controls at what point the property actually will trigger the updating process in the view model. So usually we are using property changed immediately. That means as soon as the property changes in the view model, the correlating value in the view becomes updated, and vice versa. In the moment the property changes in the control, then that causes the view model property to be updated as well. There's one exception, and that is when the user edits something in a text box or in a text box like control. In many scenarios, it doesn't make any sense that the property will be updated with every typed character. Rather, it makes more sense that the property counts as changed only when the text box loses its focus. So, and that could be seen as the moment that the property really changes. And in those cases, you would set the update source trigger to lost focus. So if you set up the property bindings parameters, then don't forget to click on the add button so that the binding will be listed in this table. And of course, there can be more than one binding. So you really have the option to set up whole sets of bindings. In WPF, for example, this is called a multi-binding. And here the binding engine is even more superior than the binding engine of universal Windows apps, so apps for Windows 10, because multi-binding at the moment at least is not possible in MvvM scenarios or in binding scenarios for universal apps. Okay, so after I did that, I can click OK, and I'm just going to the next step, and this is again, I'm setting up the property bindings for this. And in this case, we really, for the entered formula, need a two-way binding, and we need it on lost focus. So I'm getting, again, the text property of the formula text box, and this is a two-way binding on lost focus. Entered formula is OK. I again click the add button and here the OK button, and finally we do the binding of the command. This again is a one-way on property changed immediately, and the control property in this case is the command. And on that side, oh, by the way, you can always search for the property in here, and it will be selecting what it finds in the list. So press the add button and click OK, and that's it. With that we have established our bindings, and yeah, it should work. Oh no, there's one additional thing we have to do, and of course we need to instantiate the view model at runtime and tell the MvvM manager what view model we are actually using. So, and to this end, I'm just going here, and I already prepared the necessary lines for that. So in this case, after the initialized component of the main view, which is the initialized component of the form, we're just creating a new instance of main view model. And then the only thing we have to do is assigning that instance to the data context property of the MvvM manager. And if you know about XAML and WPF and probably Windows 10 universal apps, then you know that this is almost the same as you would do it in those UI scenarios. So after this is set up, I should be able to start the app. And then let's see what's happened. I'm typing in the formula 40 plus 2, press the calc button, and you see that the result is written into the label by the view model through the binding. Okay, so after we completed our first version of the MvvM calculator, let's do a couple of improvements. You saw that implementing the properties the way we did is actually quite an effort. It's simply too much typing. So to simplify that, we're going to use a helper library called MvvmForms base, which also comes as a NuGet package. And this MvvmForms baselib provides a base class called bindable base, and this class is exclusively for implementing iNotifyPropertyChanged compatible properties in a really simple way. So let's take a look. First, I'm adding the NuGet package to our ViewModel library. And for that, I'm going to this NuGet package manager, and I'm looking for MvvmForms base, and I'm installing the latest version. Okay. So now I got this one installed. I'm no longer implementing iNotifyPropertyChanged in our view model, and instead I'm inheriting our main view model class from the base class bindable base. And let's take that into scope with a light bulb. So since I'm not longer myself responsible for raising the event, I don't need the event actually. That event is defined in the bindable base. And now I can refactor my properties and show you how simple it actually is to implement properties that are raising the events when their value gets changed. So I'm calling the method of the base class setProperty, and I'm just passing the backing field, in this case my result, and the value, and that's the only thing I have to do. So again here with entered formula, calling setProperty, and I'm passing my entered formula and value, and again I'm doing this here. Okay, so I also no longer need this calculation faker, and I also don't need the relay command because all that is defined in the base class as well. And so I showed you how to do that in terms of refactoring the class, but I've prepared a code snippet here in the clipboard ring, and I'm just dragging the complete version of it in here. So we have really now a complete version of the main view model. And as you see here, there are some types for which the imports haven't stated at the beginning of this code file. So I can do this real quick here and get the import keywords for that. So what changes did we make? First of all, in the cald command proc, we now really have the class that calculates what the user entered. So the result from now on is not only 42 all the time, but the actual result. And you see here how the formula evaluator class is being used, and it's just instantiated at the top, and it is passed the formula as string, and the result just calculates what's in there as string and brings back the result, which then goes into the view model property result, and just assigning the result then lets it show in the view. Another thing is that we actually used the can execute calc command method, and this one actually is very easily to understand as well. So if the user entered something in the text box, then the calc command is available. If there is nothing in the text box, the calc command is not available. And this is how we control the can execute flag. And the can execute is actually bound to the enabled property of a command button. So the command button automatically gets disabled when there is nothing to calculate, and it gets enabled when the user entered something in the formula. And to test this, start this. And as you can see here now, the calc command is disabled because nothing is in the entered formula text box. And if I'm starting to type an expression I want to calculate, like 12 plus 12 plus 12, it's not working. And the question now is, why is it not working? And that's actually quite simple to understand. So let's go to the view and see what the relation between the text box and the calc button is. Up to now, we bound the text box property against the view model in the mode property change on lost focus. But this is a problem now because we need to establish a binding where we can, in the view model, immediately check if something is in the text box. And for that, we just have to change the binding mode. And to do that, I'm again finding the property bindings property, and I'm calling the designer dialog. And now I'm quickly changing the binding mode from two-way on lost focus to property change immediately. And then I'm clicking edit to override the current settings, and I can leave this dialog with OK. And now let's try that again. Again, I'm having the form, I'm starting to type, and in this case, you see the moment I have something in the text box, the calc button becomes available. And when I'm deleting what I typed, and I'm deleting the last char, then the calc button again becomes disabled. Now let's check if we really can calculate something. And I'm clicking the calc button, and there's the result, and it is not 42, so we can even enter something more complex here, like 12 plus 12 times 2 plus times 3 plus 3. It seems to be working all right. Well, we have our first little MvvmForms app up and running. Don't you think that's cool? It's really just a very trivial app, but the principle is the same for bigger apps. And at ActiveDevelop, our biggest Windows Forms applications are larger than 1 million lines of code, and they are containing way more than 400 views and view models. So MvvmForms really scales. So let's remember the original title of this webcast, which says, "From Windows Forms to mobile first, cloud first, the feasible way." That means we should really implement a Windows 10 universal app now. So let's do that. And when I'm showing the following steps, I'm not going into much detail of how a Windows 10 app and XAML is working in principle. Not only are there plenty of webcasts of that, if you need support to train your team in that, or if you need help to plan your migration of your Windows Forms app, just get in touch with us, and the training in XAML, Xamarin, and MvvmForms is always also part of our services. So let's see now how the view model code we already have can be reused in a Windows 10 universal app. I'm adding an additional project now to this solution. And this time it will be a universal Windows app, again in C#. So we got a good mixture of Visual Basic and C#. And by the way, it doesn't really matter if your view models or your views are in C# or in VB. MvvmForms works equally in both languages. So I'm picking C#, Windows, and now I'm adding a blank Universal Windows app. And I'm calling this one MvvM Calculator. let's call that modern. That implies Windows Universal, don't you think? And I'm clicking OK to add the project. So universal apps are designed by using XAML. You probably know this from Silverlight or WPF. And when we are opening the main page, you see here is the XAML code and the defined page. Well, actually, a page in XAML or a page in a universal app equals a form or a user control in Windows Forms. So I already prepared the basic XAML code for our app again in the clipboard ring. So I just can pull the basic view elements here from the clipboard ring into the XAML code. So we have the basic definition of the form already here. And also we need an app bar which contains all the command buttons our app needs. So I'm getting this one as well and drag it in here. So for the time being, I'm just needing the accept button, and let's make that a little bigger to see how it looks. So this is basically the same UI definition we had in Windows Forms. We have a text box where we can, or where the user can enter the formula, and we have a label for the result, and we have a button that the user can press the moment he wants to calculate what he entered. And in contrast to our Windows Forms app, the binding here in XAML is done with a binding keyword. So instead of assigning the text property directly in the XAML, I'm just stating that I want to bind that, and in that case, I'm telling the binding engine that I want to bind the entered formula of the view model. And again, this is almost the same as you learned it in Windows Forms. We have a two-way binding, and we have an update source trigger, which works with property changed. So yeah, it's really the same in principle as we did it in Windows Forms. And the only thing left to do, we also already know from the Windows Forms version. So we have to instantiate the view model and assign it to the data context property of the view. And this is done the same way. So I'm changing to the code view now. And again, we have here this initialize component, which, well, basically works the same way as in Windows Forms. So at this point, I can, use. Oh no, there's one thing we have to do. Of course, we need to reference our view model library so we can access the view model. And now we can actually use the view model. And let's say this is VM for view model equals new main view model. So let's import that namespace. And this now works a little bit different than compared to the Windows Forms app. We're not assigning anything to a component. We can in XAML assign the view model directly to the page. So I just type this is C#, this dot data context equals VM. And of course, this is obsolete, so we can just write data context equals VM. So let's make this the start project. And let's compile that to see if, okay, that's okay, build succeeded, 2 up to date, 1 skipped. Oh, that 1 skipped is not really good, so let's go to the property of the solution, to the properties of the solution, and we should build and deploy the modern app. Say apply and OK. And now let's try to start this. Okay, there's one more thing we have to do. Since we used the MvvmForms base library in the ViewModel and we are referencing the ViewModel, of course the MvvmForms base library has to be included in the modern app as well. So let's quickly go to the NuGet package manager for the solution. And we switch this to install. And now we can see MvvmForms base is not applied to the modern MvVM calculator. So we can just click this, click on install, and making sure that this project also gets access to the MvvmForms base library. Now we can close the NuGet package manager. We no longer need that. And let's rebuild the solution and see if this now compiles. And let's start it. Okay, so here's our UI. And let me just try to enter something here in the box. And as you already probably saw, the moment I started to type things into the text box, this button here enabled. And if I now click on this button, there shows the result. Isn't that amazing? We did not change a line of code of the actual logic layer of our app to make it work as a native Windows 10 app. And we would not need to stop here. Making an iOS or an Android app out of this is equally easy. But those are not the only advantages. ViewModels are very easy to unit test in complete contrast to what you used to know with Windows Forms code behind. So MvvmForms gives you a real cool alternative to introduce a proper architecture with real separation of concerns and the real ability to do extensive unit testing and to reach a real big code coverage. So that's all for now. Remember, MvvmForms is open source and you find it on GitHub. And of course, as you just learned, you find it on NuGet. In its current version, you can use it completely for free, even in commercial applications. So please try it yourself. And if you need special implementations or adjustments, or if you need support with the migration of your large Windows Forms app, just talk to us. We're here to help. Thanks for watching. Bis bald.